Imphytek Powders is a new joint venture that combines Aperam's expertise in nickel and specialty alloys with Tekna's unique wire plasma atomization technology. The company is dedicated to developing new cutting-edge powders and solutions for advanced manufacturing technologies, including an outstanding nickel-based powder. Our powders offer a high degree of sphericity, controlled particle size, high density, bulk and tapped, limited porosity or gas inclusion, and minimal satellite content. To produce our powders at an industrial scale, we use a continuous process from wire. Using a unique plasma atomization process, we produce a highly spherical nickel alloy powder that combines high packing density with excellent flow properties, that is designed to meet the complex design and manufacturing needs of the most demanding industries.
Hello and welcome to this webinar dedicated to plasma atomized powders in the additive manufacturing sector. Today we'll be discussing the benefits of plasma atomized powders and the added value that they can bring to 3D printing applications with the manufacturer of the powders, Imphytek powders, and a customer we are Additive. My name is Alex Senna. I'm a journalist. I'm delighted to be your host and delighted to welcome Ellen Brooke. Hello, Ellen. You're the Managing Director of Imphytek Powders. And we have with us online, I think, Amine Bouissef, who's the Operations Director of We Are Additive. Bonjour. Hello, Amine. You're with us. Hello.
Bonjour. Hello, Alex.
Right, we'll be talking to you in a minute, but I'm going to start off with Ellen. Could you tell us a little bit about Imphytek Powders?
Yeah, with pleasure. So Imphytek Powders is a 50-50 joint venture. It's between Aperam Alloys Imphy and Tekna Plasma Europe. So just a few words about our shareholders. Aperam Alloys Imphy is a division of the Aperam Group. It's in the top 3 of global producers of nickel and specialty alloys. It's based in Imphy in France, where the name comes from, obviously.
Yes.
Yeah, absolutely. Which incidentally is where precision metallurgy, which is another word for alloys, was actually developed. So it's a company which also has a philosophy in its DNA of producing one powder or one product, for every different kind of applications. On the other hand, Tekna Plasma Europe is a subsidiary of Tekna Advanced Materials, which is headquartered in Sherbrooke in Quebec. And they are the world leader in inductively coupled plasma atomization technologies. And they've been just celebrating in 2020 their 30-year anniversary and have been producing powders for over 25 years. So there's a lot of
quite an international group.
Yeah, and lots of know-how behind it as well, because even if Imphytek is a relatively young company, we started our productions in 2020. We have a whole bunch of know-how behind us.
Okay, so you told us where you're based in Imphy, but who do you deliver to? Where are your markets?
Actually, the company is based in Mâcon in France, which is let's say an hour away from Lyon, just to give an idea. And around about 200 kilometers from Aperam in Imphy. And that means basically, Alex, that we've got a 100% made in France supply chain. However, we're a company that has a global reach because we deliver companies throughout the world, and also supported by the sales network of Tekna and Aperam in these countries. And so that means that we have a local presence and can continue to be very responsive to the customers and their needs. So in terms of applications for our powders, they go into 3D printing, as you mentioned, but also others like laser cladding, metal injection molding, amongst others, directed energy deposition for industries such as aerospace, automotive, energy, and other sectors.
Okay, great. So we know a little bit about you, but I think you have a presentation to show us a little bit more about your product.
Absolutely. So if we look at the slide, what I wanted to start off with was basically the manufacturing process. So we mentioned that Techno are a leader globally in terms of atomization. And so here we can see a schematic of the induction tower. So on the top left, the wire is fed in a continual process into the induction plasma torch. Now this induction plasma torch reaches temperatures of 10,000 degrees, which I'm told is something like the surface of the sun. And this instantly atomizes the metal wire, forming droplets. And thanks to perfectly controlled gas flows, these droplets fall down the tower and become perfectly spherical in shape at the end. All of this is happening in a totally controlled atmosphere. And as you can see, metallic filters recycle these gases so that these can be fed back into the induction tower again. So we'll come on to it a bit later on in the presentation, but not only can this technology produce powders from wires, it can also take used powders which have been through the 3D printing application and reprocess them, which is super exciting, almost as new, so they can be used again in the industrial printers. So we love our powders because they're perfectly spherical. They have very low porosity. We'll come later on to what does this actually mean. A very low oxygen content, high flowability and high packing density. And all of these characteristics are super important for the printed part. So if we move on to the next slide, please. We talked about the atomization. On the left, you can see the atomization tower. The next step of the process is what we call sifting. And the purpose of the sifting is to take the powder from the atomization process and basically create the recipe for the application for which the powders are destined for. So they're all done under neutral atmosphere again. At the bottom of the second picture, you can see the containers where the sifted powders are put in. Then it moves on to the third picture, which is what we call blending. And blending is important. Why? Because it takes the powders and makes them perfectly homogeneous. So that means that when they're put into a printing cycle, you get the same characteristics from the beginning to the end.
Looks like a capsule on the moon or something. It's really impressive. Wow.
Yeah, you have to visit our factory one day, Alex, because it's space age, I would say. So if we move on to the next slide, I wanted to talk a little bit about our product offering. So currently, Imphytek is offering powders in 3 superalloys, 718, 625, and HX. And these powders have all been engineered and optimized for different additive manufacturing applications, as you can see. Of course, and as to be expected, this is done in an environment where the factory is certified to AS 9100 and ISO 9001. So we have on stock in our production facilities in Mâcon powders ready to ship. But of course, we're perfectly willing to work with our customers to design specific powders as can be needed. If we could move on to the next slide, please. Now here I wanted to give you a technical comparison between plasma atomized products and also other kinds of powders which are available on the market, notably gas atomized. And what I'd like to draw your attention to first of all is the images that you can see on the bottom of the slide, comparing the first 2, which are gas atomized powders, with plasma atomized powders produced by Imphytek. And the first thing that you can see is the plasma atomized is super regular, it's super spherical. We don't see any unusual powder forms. And of course there are very little satellites. Satellites are a little bit, the moon to the Earth in powder language. So it means that the powder is very spherical, 98%. There's a very low porosity, essentially due to the oxygen content of the powders, which is down to 80 parts per million, which is at least half what we found in the gas atomized samples that we analyzed. And this is important because it means that the powders can be used more times than a gas atomized powder. We have good values on apparent density, good values on tap density, and excellent flowability of the powders. And this is something that I think everybody who knows Techno powders has experienced that for quite some years now.
Well, that's fascinating. I mean, really interesting to get an insight into that. What are the added values that your powders bring to your customers exactly? Tell us about that.
Well, of course, our powders are one part of it. You know, the customer's expertise in their printing is the other part of the puzzle. But Alex, the added value that we see of all of these technical characteristics comes down to say 7 specific points which I'd like to address. First of all, that we believe that the shape of the powders enables specific designs, more complex designs to be achieved thanks to plasma atomized. As we were mentioning earlier as well, the lower oxygen content and the low porosity improve the mechanical characteristics of the printed parts. We believe also that you can print faster with our products. The products are more accurate, and that's important because it means that there's less post-processing of the printed part, which is a certain time advantage. We mentioned also that we can use our powders in more cycles in the printing process. And this means as well that there's less powders at the end of the cycle. So that means definite downtime reduction. When that means, you know, you have to stop the machine to basically remove the powders. So this goes to also the question of sustainability, which I think is super important. Let's not forget that Aperam, who's part of the shareholding of Imphytek, as we were talking about, is the leader in its class in terms of CO2 footprint, has commitments to reduce its carbon footprint today by 30% in 2030, to be carbon neutral by 2050. But that's not all. What Imphytek wants to be able to offer to its customers is the ability to take those used powders and bring them back to as better than they were before.
Right. Okay. Well, that was fascinating. Thank you very much for those explanations.
Yeah.
I think we're going to hand over now to Amine. As I said, you are the operations director of We Are Additive. Perhaps, Amine, to start with, if you could tell us a little bit more about your company.
Yeah, Alex. So We Are Additive is a company specialized in the polymer and metal additive manufacturing. And we are part of the We Are Aerospace group based in Montauban, France. We are mainly active in the defense and the aerospace market. And that's all for We Are Additive. I'm going maybe to show you a quick overview about our production facilities. As you can see, we have 8 machines, metallic machines of different manufacturers. We produce for our client parts in titanium, in stainless steel, in aluminium, and of course in nickel alloys. So we can move to the next slide. So why we choose Imphytek powder. The story of our collaboration with Imphytek starts with the concrete issue during the industrialization of a real part, which presented a real technical constraint. As you can see in the picture, we had a problem with the complex shape of a surface with a thickness of 0.5 millimeters. So the problem was that we had throw porosities on this surface, which we could see under the white light. So we carried out several tests with different powders, including Imphytek, in the same printing conditions, and the result was clear. Imphytek powder allowed us to obtain a macroscopically hermetic surface on this case. So that's why we choose Imphytek powder at the beginning. At the end of these trials, we were very confident about the macroscopic aspect, but we still need to confirm the mechanical properties, so we carry them out.
Okay, can you tell us a little bit how Imphytek powders products have met we are additive expectations, and I know you made a large amount of tests. Could you tell us a little bit more about those, please?
Yes, Alex. We did several tests. I can show you the results if we can see the slide, please. So first of all, it's very important to point that the following results were obtained with the specific heat treatment of 760 degrees for 5 hours, and then a stress relief of 650 degrees for 1 hour. But what is important in this slide is to see that we obtain an average porosity rate of 0.33%. It's a very good result, and mainly in our customer specification, we had to be under 1%. So that's the good point when we use the Imphytek powder. I have other results of tensile tests in the next slide, if we can move on to the next slide. So here there is the customer specification on a concrete industrialization. The customer specification were to get to 1,000 megapascal in the yield strength, and the mechanical strength should be more than 1,250 megapascal. I put all the results on all the samples in XY direction or in the Z direction of printing. We see that the results are good. They are under the customer, they are better than the customer specification, and we have a little bit variation of values, and that's very important for the quality of the samples. More important that we have an elongation of 20%, and all the failures were in the useful area in the samples. And it's very important also to say and to point that all these results were obtained with heat and heat treated samples. Can we move to the next slide, please? It's okay. That's the compliancy of the powder. So since we start working with the Imphytek powder in 2021, we received 1,250 kilograms of powder in 4 different batches. In our process, we carried out systematically external laboratory and independent laboratory tests of the chemical composition, of the density, the tap and the apparent density, and also the particle size distribution. And all I can say in these 4 different batches, we did not detect any discrepancies between the certificate of Imphytek and the result that we obtained with independent laboratories. So in the context of a customer qualification of a big name of aeronautic sector, we still have to do more tests and trials. In April of this year, we don't have the results, and I cannot show you the result, but we will do another tensile test, fatigue test, fracture toughness test, fatigue crack propagation test, and we still don't have the result. But when we see the tensile results and the microscopic result, we are very optimistic to obtain good results with this powder and with the quality and performance of the Imphytek powder.
Okay, thank you very much. Amin, could you tell us what's next in terms of your cooperation?
Yes. So today we want to extend more our collaboration with Imphytek by sharing some challenges. So in particular, the powder recycling. Today we reuse the powder for 30 or 35 times, and after that we keep a significant amount of residual powder that we cannot we can't use. So it will be very important or great for us if Imphytek offered us a recycling solution or a reconditioning solution for this amount of residual powders. And I think Ellen talked about in his presentation, but it will be very important for us.
Right. Okay. Well, thank you very much indeed, Amine. Merci beaucoup. Ellen, over to you. So could you tell us what's next for Imphytek powders?
Well, I mean, first of all, thank you very much, Amine, for that presentation. We really appreciate you being here with us as well. And I think that the point that Amine is raising about recycling is very important. Because why? We know at the end of the production process, powders do remain. Often it's a difficult and a costly process to get them removed, and we really want as a company to move forward on offering this recycling solution. Our trials, which are taking place in Mâcon on an R&D facility, can show, as you can see on this slide, that in terms of how the powders look before and after, we can totally see that the spherical shape is coming back. The PSD doesn't change in the process significantly, but what's most important is to see that the oxygen, which is what's also coming, that's a limiting factor on the number of printing cycles, is dramatically reduced and comes back to how it was before. So we're really keen to pursue collaborative projects with customers to test this process on their products, so that in the coming future we can offer a recycling solution, which is going to be very important going forward. I think the other thing I'd like to touch on top of recycling is that I'm pleased to announce that we're going to be doubling our production capacity in the coming months, hopefully by the end of this year. And this is also important because it means that we can follow our customers' growth. We can extend our product range from what it is today, but we can also work on the grades of the future, which have been designed by Aperam Alloys specifically for additive manufacturing applications. So we're really looking forward to that as well. Thank you.
Thank you very much indeed, Ellen. I've certainly learnt a lot. Et merci beaucoup, Amine. Thank you very much, Amine. I hope, like me, you've learnt a lot about plasma atomized powder and, of course, its benefits to additive manufacturing processes. Anyway, thank you very much for being with us, and we'll see you soon. Goodbye.